So now we're going to be transitioning to the next subcategory, which is fallacies of induction. This is going to be some type of data manipulation involved in this. Yeah, and like different assumptions made about data. Now, the first two that we're going to cover are kind of connected, and they're again kind of inverted versions of each other. And that's going to be the fallacy of composition and the fallacy of division. Now, the fallacy of composition is basically saying that because a component of a thing, a component or a part of a thing, has a characteristic, the entire thing has the same characteristic.
Right.
So a very common example of this one is, well, this tire is made out of rubber. Therefore, the entire car must be made out of rubber.
That's not true.
No, it's not, and it doesn't make any sense. And there's all kinds of other examples that you can have, but it's important, especially for this, that it's not multiple pieces must mean that the whole has. It's one data point is reflective of the whole. So it's a person taking one data point and saying it's reflective of the entire thing. And this doesn't have to just be like objects, right? This can be another example I like to give. This quiz is difficult, so the entire class must be difficult. Right? Just because there's a single quiz or homework assignment that is difficult and challenging does not necessarily mean that the entire class is difficult and challenging.
Right. Could that be for like traveling in Europe and you see a statistic of like, oh, people get robbed there 2% of the time, therefore I'll get robbed there? Or is that different?
That's different. That's going to be kind of a subcategory of fake precision.
Okay.
But that's good. That is very good to keep in mind. Using statistics incorrectly, essentially.
Okay.
But yes. Yeah. So that's basically the fallacy of composition. And then on the kind of inverse side of that is the fallacy of division, which is saying that because a whole thing has a characteristic, a single component must have the same characteristic. So a classic example I like to use is this: because this computer can browse the internet, the spacebar on its own can browse the internet. Right? Computers are very complex machinery. It is definitely something that works to achieve an effect as a whole, not necessarily any single component that can do that. Right? So, another thing, going back with the car example, this car can go 100 miles per hour. Therefore, this hubcap can inherently go 100 miles per hour.
Right.
So it's basically making assumptions about particular, and again, we're going from a whole to a single component, not multiple components, to a single component. That's going to be pretty important. And for both of these things, basically, there are times where you can actually conclude things about components and things about the whole based on each other. So basically, what you have to prove is that the characteristic that you're talking about is transitive.
What does transitive mean, Johnny?
Basically means that it...
You don't even know. You're just saying words.
Transitive basically means that it stays the same from one to the next. So it can be transferred from one to the other. So my classic example of this is this brick, right, is a pound. If let's say I had a brick, right, it's a red brick, kind of stereotypical brick. This brick weighs a pound, therefore this brick wall weighs a pound, right? That's bad. That's a fallacy of composition. But if you say this brick is red, therefore this brick wall is red, then that the color there, that's a transitive property. That's something that's going to stay consistent from one to the other.
So this pixel is red, green, and blue. Therefore, the screen is every single color ever.
Maybe
because pixels are only red, green, and blue, and they make everything. So
yeah. So exactly, yeah. So it would work that way. So this is again not one that necessarily comes up all the time, but it is something to be aware of.
Yeah.
And now this next one is a fallacy that everyone commits all the time.
Wait hey, that's a fallacy. I heard that. I'm smart, but I want to interrupt that. Would that be applicable to like groups of people? So say like,
I generally discourage from using it for thinking about groups of people, because it's again going from either a group to a single individual.
Right.
So if and then from a single individual to a group, and usually when it involves people, it actually better fits the next fallacy we're going to be going over.
Okay, cool.
So it's not that it can't. It's that generally those types of generalizations fall under hasty generalizations, which is our next fallacy, which Zach definitely recognized I was committing and kind of introducing that. So when
it was more your tone. I didn't pay attention to your words, but your tone had that. Oh, I'm making a funny here.
Yep. That's definitely a tone that my students recognize, and I basically conditioned them to laugh at my very bad jokes. And my students.
I did the same thing with my wife.
I had a student at one point in an essay write, basically saying that I'm very good at making them laugh, even though I'm not actually funny, because I conditioned them to. I was like, I don't know if I put that in an essay that you're wanting me to grade for you, but it was hilarious. It was actually really funny, and I complimented the student on their astute observation of
well done
my humor and its lackluster nature.
So hasty generalization?
Hasty generalization. And this is basically coming to a generalized conclusion with insufficient evidence. So this is when you make a generalization where you just don't have enough information to substantiate your conclusion. It's just not there.
How do you ever decide that it's enough information?
So again, this is where we kind of get into subjective versus objective, right? What's considered enough information is going to be subjective. I would say following the scientific methodology, and not just following that, but also making sure that any survey data you're gathering, it's peer reviewed, it's and there's all kinds of criteria for the scientific method, that is peer reviewed, and especially that it can be recreated. It can be in other contexts, you can observe the same information.
So jumping back to the begging the question fallacy of bee stings hurt because they hurt.
Because they're painful, yeah.
Yeah. That could also, I don't have enough conclusion. That's not right, is it? My brain is trying to connect things.
So I would still say that you can't necessarily conclude if the only information you have is that you've been stung by 2 bees and it hurt. Or if that's the only information you have, you can't necessarily conclude that all bees will hurt you, right? But obviously, if you have pain receptors and the bee has is it venom? It's not venom. Bee venom?
I'm not a bee man.
Venom? I don't know, but assuming that it's similar context, and you do research and you find like, oh, this is a general trait for like the vast majority of bees, that they have stingers that inject venom, then that's no longer just based on the 2 instances of you being stung.
Right. Yeah. Okay.
And so, even though I don't have exact statistics on how often hasty generalizations occur, I will say, and this is somewhat anecdotal, and this is somewhat of a hasty generalization itself based on my own personal experience, which is not sufficient to come to any meaningful conclusions, but we're still going to make some assumptions to function. This is one of the most commonly occurring fallacies that I've observed. This is definitely one to be on the lookout for. People making kind of general statements without having sufficient evidence.
Cool. So what do you do about that? If you run into somebody on the street and they make I'm trying to think of hasty generalizations, but I've stopped coming to any conclusions to avoid that fallacy. That's my solution to it. But
that's one
how would
solution.
you recommend?
Well, and oftentimes like racial stereotypes are hasty generalizations. So again, from like a rhetorical perspective, if someone is bringing up a hasty generalization, then just start questioning where they got their information from. Like, well, how do you know that? Right. That's generally my approach, is to ask someone, well, how do you know that that's true? And oftentimes they'll come back to anecdotal evidence or an argument from personal experience. Well, in my experience, and even though I kind of just use that to say that hasty generalizations occur most commonly, acknowledging that, sure, we are making some assumptions there. Generally speaking, personal experience is not a reasonable or a rational source of coming to conclusions. And that's not to say that you can't trust your own experience. No, that's not what I'm saying. I'm saying that you can't come to general conclusions based on just what has happened in your life.
Yeah. Okay.
So the next one that we're going to cover is, this is again kind of an umbrella. It contains multiple versions of it, and we'll just go kind of through each version. So it's fake precision, and this one is specifically doing something janky with statistics. So doing something just really not justified with statistics, and specifically numerical data. So the first and kind of most straightforward version of this is just making up data. Saying, like I said, there's an 85% chance that Zach and I will be trending on YouTube's front page in the next 3 hours.
I like those odds.
Right. No, but those that I clearly just made that up on the spot. It's there's no real argumentative value to it. And this is one where where I want to say, like, yes, there's a difference between like malicious intentional use and non-malicious intentional use. Right? Like if you are telling someone like, hey, you need to give 110%. Right? That's literally mathematically impossible. Right? Also, I don't think it necessarily makes sense, especially kind of in view of, in light of our episode 3 discussion of like energy, brain power, willpower being tied to literal nutrition energy levels, right? It doesn't actually make sense to talk about effort in a percentage, because that's constantly shifting. But the person there is not trying to actually communicate a specific numerical reality.
Right.
They're not.
It's a concept.
It's a concept. They're trying to urge you to try harder. Right. They're and specifically, you could even go more specific than that and say they are urging you to do better than you have in the past. Right. They're urging you to go on beyond even what you think you're capable of. Right. But we're not actually, and I would say, like, telling someone to give 110%, unless it's in kind of an abusive context where like they are doing their best and you're trying to push them, well beyond what they're capable of, right? That's different. That's not good. But if you're trying to do it to encourage someone to achieve something they didn't think was possible, right? I would say that's an intentional use of fake precision. especially if you're aware of what fake precision is, but it's not a malicious use.
Okay.
Now, on the other hand, if you're in a debate and maybe you're losing the debate, and let's say, give me a really silly debate topic.
Carrots grow out of trees, not the earth.
Okay, and you just randomly say that 85% of people who believe that carrots grow in the earth are murderers.
Whoa, that many? I don't want to be associated with those guys.
Right, now that's intentional and it's malicious, right? Because you are now lying, and it's not lying to like encourage someone, it's lying to deceive someone for some type of personal gain, in this instance winning an argument. And fake precision is particularly, and when used maliciously, is a particularly nasty fallacy, because the human brain likes precision.
Right.
Your brain is going to default to, oh, this is true, if someone gives a really specific number, right? And this is why it can be super effective during a debate if someone just makes something up. If I were to say maybe 85% is too pretty a number to be easily believable. If I say 96.72% of scientists believe that rain is actually little gopher tears, right? Then, again, assuming that the statement that follows the statistic isn't actually as ridiculous as rain is gopher tears, but the brain defaults to believing it because you're making that assumption that specific numbers equal work behind it, or research behind it.
So, question regarding purposefully lying to deceive, being malicious. Plenty of magic tricks use fake precision to be like, there's a 0.5% chance. Like, if you shuffle cards, it's most likely in a random order that's never been done before, just because of the nature of cards. And I'm going to lose your card in the deck. We're going to shuffle it, make that percentage even smaller by shuffling it 7 times, and I'm going to find your card. Where does that fall?
So again, I would say that it we're kind of getting into ethics here, which is certainly like depends on what system of ethics you're using. If we're using the ethical system of Immanuel Kant, he would say any deception and lying is inherently bad, so don't do it. I personally would not agree. I think magic is awesome, and I think you should continue doing magic. So I would say, like, in that particular instance of magic, it would depend on kind of what your goal is. And I'm even going to nuance it further, because I said deceiving someone for selfish personal gain. Right? You could be a magician who literally doesn't care whether or not your audience is enjoying themselves, and you're literally just doing magic to make money.
Right.
I would say that's not immoral. That's not bad.
But a magician who does the whole, I'm talking to your dead relative to make money, that's crosses.
Exactly. Because I would say, again, I guess this is somewhat like a social contractarian thing, where the magician and the audience, there's sometimes a literal contract through buying a ticket to watch them, or if you're like kind of a street performer magician, then there's an exchange happening where you are providing entertainment, right? Yes, it's entertainment through deception. Technically, acting and movies, they're deception, right? So it's providing entertainment. You're providing a service that involves deception, but your audience is kind of knowingly, like they're I guess willingly being deceived, right? They're opting into being deceived. And so I would say, for that reason, it's not, even if you are using fake precision, I would say that's not malicious, because it's agreed on between the parties.
Right.
Right.
Cool. Just making sure I'm not being a logical fallacy, man.
I mean, you are. Magic is built on logical fallacies, but it's not malicious logical fallacies because the purpose is to entertain.
Cool.
So that's one version of fake precision. Then the next version of fake precision is basically coming to an unrealistically specific number in a mathematically unjustified manner. Now, and that's like a really roundabout way to say something, but here's a really good example for it. Okay, let's say, and I'm not a paleontologist, so I'm probably going to get the age of things wrong terribly here, but let's say you have a dinosaur bone, right?
Okay.
And you carbon date it, and the carbon dating comes back and it says, okay, this is 10 million years old. Again, not a paleontologist. I don't know like what age range dinosaur bones would fit into. All right, but it says the carbon dating comes back and it's 10 million years old. 10 years later, someone looks at the dinosaur bone and asks you, hey, how old is that? And you say,
1 million.
well, no, so you say, well, 10 years ago we carbon dated it and it was 10 million years, so it's 10 million and 10 years old. Right? That's not true.
Right.
Because the initial number was an estimate, and particularly it was a rounded estimate because we can't be as precise. And so you can't take an imprecise number, like an estimate number, and just tack on a specific number, which brings you to a specific number outcome and say that that is accurate. It's not.
Okay. That makes sense.
Yep. And then the third version of false precision is actually applying statistics to specific instances incorrectly. So applying statistics to specific instances incorrectly. And this is where your getting robbed example comes in. Right? So if you say, you know, let's say you go to country A and 10% of tourists are pickpocketed in that country. Right? You can't then conclude, like, let's say you go with a group of 10.
Right.
Right? You can't then conclude that one person from your group will necessarily be pickpocketed.
Because that's not how stats work.
Exactly. That's not how statistics work. The same way, and another example I use is, you know, there's, I use this example. I should actually remember the statistics. So I'm actually going to commit the first version of fake precision and make up a statistic. For something.
I feel malicious.
Well, here the purpose is education. So, yeah.
Listen to Kant, not your heart.
So let's say that 6% of the US population suffers from some type of heart disease, right? Mm-hmm. And so you have a group of 100 students at a school. And so you say that means 6 of you currently suffer from heart disease.
Mm-hmm.
And that is, again, a bad application of statistics. You can't conclude that. Specifically in that instance, it's actually much likely that the students will have a much lower rate than the national average, because the national average is not indicative of which specific person will have heart disease. There are other factors that are significantly more important and valuable in predicting your risk of heart disease than just the national average, right? Your family history is significantly more important than the national average. Your personal health lifestyle is significantly more important. Your diet, you know, whether you smoke, all these other things play into and are much more important variables in predicting whether or not you specifically are at risk, as opposed to the national average.
Which makes sense.
Yep. So And again, avoiding fake precision is tough, right? You know, on the one hand, don't, like, one of them is really easy. Don't maliciously make up statistics to win an argument, right? Don't do that. But my kind of more broader recommendation is just to use statistics correctly. Use statistics correctly, which I say that because statistics is an entire field in mathematics. There
Right.
are people who are much better suited in teaching you how to use statistics correctly.
But a hasty generalization that I would make is that you can make statistics say anything you want to say.
Sure. Yeah. And yeah, there's all kinds of additional stuff. So, you know, you can actually use a graph maliciously, where depending on like what
Where
increments
you
you set
start
things
the
at. Exactly. So there's all kinds of other things that statistics and graphs and things like that can actually be misrepresented very easily. So I would actually recommend that you look in, that you, being you, Zach, if you're interested, but also the audience, would look into it more if that's something you're interested in. But that's definitely something to be wary of and something to take a closer look at. So not just statistics, but even there's a whole field of ethics of how to present statistics in an ethical manner. So I would recommend.
That sounds boring.
I feel like that's a hasty generalization.
Yep. Yeah.
So the next one that we're going to cover is called a false analogy. A false analogy. And this is very straightforward. It's saying that two things are similar when they really are not. Saying two things are similar when they really are not. And this is, again, going to be somewhat subjective, right? How identical does something have to be to another thing for it to be considered similar enough? And so this one, there's no like hard and fast rule for determining whether or not something is a good comparison or not. But again, developing that self-reflection, looking at specifically what the person is drawing, what type of conclusion a person is drawing from an analogy, a comparison, is going to be really important in evaluating whether or not something is a false analogy. So kind of the mildly political example I like to bring up is sometimes, especially if the politician is formerly in the business world, they will say, hey, I've run businesses. I'm a business person. I'm a CEO. So I know how to run a country, because running a country is like running a business, which it is not. On so many levels, it is not, right? And if you're a private company, your competitors don't have nuclear weapons, right?
You don't know that.
I guess, again, I am making an assumption here about the underground business market for, IBMs, but again,
not IBMs. That's the wrong company. I think you mean International Ballistic Missiles. Wait, Intercontinental ICBMs. ICBMs, not
thank you.
IBM.
Oh man, that's awesome. Yes, ICBMs. Thank you. That's really funny. I love that. Yes, ICBMs, right? So that's not a general concern. If you're, if you own a mom and pop shop, right? You're not worried about like the bakery down the road invading your store with armed militants.
Yeah.
Right. And so, you can fix those types of analogies by maybe narrowing the scope of what you are trying to draw, what conclusion you're trying to draw from that analogy. Now, I would say a much better conclusion than saying like I can run a country, right? Because running a business and running a country are two very different things, would be to say I have experience in picking experts in their field to help run the areas that should be run, right? Yeah. That is something I definitely think a CEO, a business leader would have experience in, and would actually be very useful in being in a position of leadership on kind of a national or state or even city level. right?
So you said that was narrowing the scope.
Mhm.
Could you also broaden the scope to make it more like the thing that for some reason the analogy that popped into my mind was the classic. I think it might have been Plato who talked about the chair, like the concept of a chair, and like you can take a tree stump and you say this tree stump is like the queen's throne because you can sit on them, and that would that be narrowing or broadening the scope?
I'd say that's narrowing because you're talking about a
Okay.
very specific function, right? You're not
Okay.
comparing materials, not comparing like who sits on it. You're talking about literally just one function or
Okay.
potential use of a thing. So I would say that'd be narrowing it. And another, even if someone says, "Well, I'm a business leader, so I understand the economy," I would still say that a national economy and like the magnitude of something is going to be different. But again, especially when we're talking about like the president's office, for example, right? That's not actually an office unless you're reelected for a second term. That's not an office that anyone's technically qualified for with previous experience, right?
Well, that's an interesting point.
No one has had the level of responsibility of a president before they are president.
Hmm.
So now I think certain people are better qualified. Certain people have better qualifications, have skills that are better analogous to the skills required for the presidency. But so again, just making sure that with an analogy, even if if you're kind of drawing a comparison between two things that are pretty different, you can, and again, this is super subjective of what's close enough to make a comparison, but making sure that you're drawing very limited conclusions from an analogy.
Okay.
And you're not
There
saying that
was.
like,
Go ahead.
and not saying something like, I've I have taken care of a pet and I've shown responsibility at that. Therefore, I'm responsible enough to be trusted with the nuclear codes.
Yeah.
Right. That's not
Well, you
on the
can't
same
drop a
level.
baby. You can't drop a nuke. Just saying.
Oh my God.
um, yeah, there's a game that it's more like an exercise, I guess, where it's practicing lateral thinking of you take two purposefully different objects or concepts, and then you start off saying as quickly as you can. So like a pane of glass and a pillow are the same, and you start talking before you can think of, and that helps you think laterally and draw conclusions. And so that's a fun thing to do. Like a pane of glass and a pillow are the same because generally they're in a square shape. Uh, and it makes your brain think of that, and so that could be a fun little exercise to help
Oh,
with your
absolutely.
false analogies.
Absolutely. Yeah, absolutely. Definitely. And again, training your brain and developing those neural pathways to being able to make connections like that, that's not only going to be able to help you think more quickly, draw connections more quickly, but it's actually going to improve your brain health long term. So we're now going to come to our final fallacy of the day.
Oh,
And
good. I'm exhausted.
good. Logic should be exhausting. It gets less exhausting the more you train your brain, actually. But so this last one we're going to be talking about is false cause fallacy. It's a false cause fallacy, and this is basically saying, and I like to, I'll give a broad definition, and then I'll kind of give the classical definition for it. So a false cause fallacy is basically misattributing the cause of something to something that did not actually initiate the effect. Now, the classical example is saying that because thing A happened before thing B, thing A caused thing B. And I like the little bit more general definition because it's not quite as narrow. It allows for kind of some fringe instances of things, but functionally, the definition of thing A happened before thing B, therefore thing A caused thing B, is a really good working definition.
Okay.
Now, an example of this is a lot of sports-related superstitions. Right? I had a student one time who said, every time I leave the room when I'm watching a Patriots game, the Patriots start to lose. And so the student would actually refuse to ever, like, no bathroom breaks, no nothing during a Patriots game, not to go get snacks.
But Patriots wasn't even his team. Just kidding.
Because he thought that there was a connection between him staying in the room and the Patriots doing well.
Right.
That is not a very well justified connection. Just because there was a correlation there does not mean that staying in the room was causing the Patriots to win. And so basically, just making sure that when there isn't a very clear connection between kind of cause and effect, that you are double checking to make sure that you can find a causational relationship between the cause and effect that you are assuming are connected.
Cool. Which can be tedious to do sometimes because the shortcuts that our brains like to take.
Exactly. Absolutely. Which is why we need to develop self-awareness.
Neat.
Yeah.
So that's everything?
That is indeed everything.
Oh man, I'm so glad that I learned everything now.
Yep.
Neat.
Yeah.
Should I do the rundown conclusion or
Sure.
Okay. So, just to make sure I got everything. Presumptions of fallacy. Presuppositions is begging the question, which is like circular reasoning, starting with the conclusion. False dilemma is a false choice where there are more options available than that are given. Sorry, I messed up my notes. I have a system and I put the wrong symbol for it. Fallacy of moderation, assuming the middle ground is the most effective, but it's not the case. And then subcategory induction deals with statistics? No.
Yeah, data.
Changing data. Yeah, that's it, data. And then you've got... I'm so sorry, my notes are all mixed up now. Hasty generalization, that's the first one?
Fallacy of, so did we did Izot. We do fallacy of composition and division.
Oh man, I am all over the place, guys. I am so sorry. Izot fallacy, I skipped that one. I'm doing the wrong notes and for some, I don't know. Izot fallacy, because something is a way, it should be that way, and that falls under the presupposition umbrella. And then induction, you do the composition, and that is a piece of a thing is representative of the whole of a thing, which is not always the case, and division is the inverse of that, where the whole of a thing represents all of the pieces of a thing. Hasty generalization, you come to a conclusion without enough information, but we can never know what's enough, so don't come to any conclusions. That's your best bet.
Okay, cynic.
Seneca to you.
That's different concept.
Fake precision is doing a specific information, and that can be malicious or not malicious if you're doing it for selfish gain and purposely deceiving. And there's actually multiple parts of that, because there's unrealistic numbers where it's like 1,000,000,005 3/4, and then there's appealing to stats to specific something.
Applying statistics to specific instances.
Instances. That's not it. That's not how I spell instances. And then false analogy. Two things are like each other when they're not. And finally, but not least of all, false causation. So because I shuffle the cards, oh dear. Because the camera falls, you don't see a trick. False cause. Eh?
Unless that is actually the reason we don't see a trick.
Yeah, that is why.
Yeah. Yeah, that's it.
Cool. That was fun.
Yeah.
That was a lot of stuff, man.
That was a lot of stuff.
If you made it all the way here, well done.
Yeah, absolutely. We may split the video in two. Again, this ended up being longer than expected.
Hey, did you see that magic trick on Instagram I've been working on? I'll do it for everybody now.
Okay.
If this works. It's not going to work, is it? Okay, I'll just do this. Okay, so this involves two different types of cards, red cards and black cards. Let me scoot back. Red cards, as everyone knows, are the most important card because they're red. And black cards are the most important card because they are black. But what's interesting is they don't like each other. And so if you put the black card there and then a red card down and then a black card and then a red card down like that, they automatically order themselves differently. And it's really weird because it just happens automatically somehow. And nobody knows why. But about 33% of the time, 33.4% of the time, it works that way. So thanks for watching.
Awesome. That's great.
Logic, magician.
Excellent. Thanks, folks, for listening. Have a wonderful rest of the day, and we will see you next time.
Bye.
Bye.